All right. First thing, let's make sure you guys are in the right place. This is Cinnamon integration testing tool for the Salesforce1 Platform. Hopefully you enjoy this session. Second order of business, our safe harbor slide. The key takeaway is that making any purchase decision should be made on currently available technology and products. My name is Yuji Nagata. I'm an architect with Salesforce. Been in the company past 7 years now, working on multiple platform teams. And I'm currently working on a team that is delivering Cinnamon. So Cinnamon is about testing. So before we start, let's talk a little bit about the current state of affair of testing on the Salesforce1 platform. So just to get some context, raise your hands if you are a Apex Visualforce developer. Do you enjoy and find valuable Apex tests? That's a tough crowd. Any of you have heard or used Selenium WebDriver? Quite a few. That's good. All right. All right, so testing on the platform. The first thing we need to understand about testing, automated testing, is that the best practice dictates that we should follow a pyramid format. What it means is that in order to have a application development that maintains your app working as you develop and as things change on the different systems that the application is built, you should have a large base of unit tests that test your unit classes in isolation to make sure that the smallest piece of code is working. On top of that, you start adding tests that actually connect the different components, maybe with different subsystems and so forth. And lastly, you have a class of tests that actually simulates what the end user of your application will be doing and seeing. So on the platform, we currently have Apex tests that serve the base of the pyramid. You can write all kinds of Apex tests to try to break your Apex code. If you consider the services provided by Salesforce platform, like the database itself as a different subsystem, your Apex tests now work at the service level. You are integrating your code that you wrote in Apex with the functionality that the Salesforce database provides, and so forth. There's some lacking in testing external systems with Apex tests, but that's what we are right now. However, for UI, we don't really have anything right now built into the platform. People have used different tools, and Selenium WebDriver is probably the most popular one, and a few of you guys, I'm sure, already have used that to test your Salesforce applications. But the reality is you have to build your own testing system. So the question is it worth it building that? So why do we need that layer of automated tests? So if you look at an anatomy of a simple platform app, you see that there's different subsystems interacting to provide service. So usually the user will access the system through a browser that is rendering HTML and executing JavaScript. That HTML JavaScript was probably rendered from a Visualforce markup page that interacted with Apex code or external systems to come up with the final HTML JavaScript. So currently, as you can see, the only subsystems that are really testable within the platform is the Apex code that you write and the integration of the Apex code with the rest of the services provided by the platform. And in reality, this is not enough. All these points that are not covered are at risk of regressing. So what kind of defects that may come out, of not having a proper automated test suite over those subsystems? So you have problems that can happen because of configuration. People, admins or developers changing the configuration of an org. For example, adding a required field can easily break a Visualforce page. View logic issues can arise as well. HTML provides some logic constructs, and if you have logic constructs, people are writing and using, and may introduce bugs there too. You have, like we discussed, integration issues with different subsystems. So your application will make some assumptions about how they work, and over the time, those assumptions may not prove valid. So a Visualforce page will have integration with Salesforce subsystem, like we saw. You might have integration with third-party JavaScript libraries. You might have integration with other web services that you access through Ajax. So in addition to that, you have the last issue can be caused by browser compatibility. So actually, browser compatibility, there are two types of issues. There's browser compatibility, where an application may work correctly in one browser and not in the other one. And the browser issues can be caused by simply browsers getting new versions. Now, browsers like Chrome and Firefox are getting updated constantly, and sometimes you'll see things regressing because of that. So as we can see, there's a need for that testing at that layer. And now, how can we do that? Usually, the first instinct is, let's just get some manual tester, test the application, and get done with it. That's how we fill that testing gap. However, as the application progresses, we can see that the manual testing is something that really doesn't scale, because manual testing does need skilled workers. It's skilled workers in the sense that they will have to write test scripts for maybe not, usually we think of manual testers not skilled workers, but they need to run through some scripts that were built by the skilled workers. So you do need skill to do manual tests. It's repetitive work, right? Upon every change, you need to run the same tests over and over. Because it's human, it's error prone. Humans are known to miss issues, to typos and such things. And it's slow, it's not as fast as an automated test. To make things a little bit more interesting, we are seeing, frequent releases of those different subsystems, which means that even if you do all the manual work and you make your application static from a point on, the different subsystems will keep being updated, and you will need to run some of those tests again. And as we move towards the cloud, more and more your application will be impacted by different systems that will have their own release cycles, and you have no control over it, and you just have to test it to make sure that the application still works. So we are really in a situation where manual testing for any complex enough application will not scale. So kind of the solution that we get to is that we do need to automate those regression tests. Now, how do we do that is a question that many of you here already answered. And in one slide, in a very high level way of explaining, to build an automated test suite, you need 3 to 4 major components. You need a test harness, which is the system that collects tests, the schedule when the test is going to be executed, collects the results, notify the users. These are usually built on top of JUnit, TestNG. Those are common test harnesses. the test harness will interact with a test script by executing the test script. The test script actually contains the intelligence of the test and can be written in any language. The test script will interact with the system under test to set up data that may need for the test, and then we'll delete the data afterwards. For this particular type of test that we're talking about, which are GUI tests, tests that the user will test the system that the user will interact via a graphical user interface, we do need a browser. The browser is what the user sees. So for the test to be realistic, they need a browser. Usually this browser is controlled by the test script via a protocol like the WebDriver protocol. And it can either be a process that runs on the same machine as the test script test harness, or it can be something that runs on a completely different computing node where you want to simulate the actual OS and different versions of the browser. So you actually need a different machine to do that. And you want to run these tests in parallel too, so you might end up using virtualization to achieve that. And the browser will ultimately interact under the system under test. So Cinnamon is a browser-based, integration test, and it does implement the test harness and test script part of that architecture. So Cinnamon is cloud-oriented. What it means is, the test harness and test scripts are hosted on the cloud, more specifically on our Salesforce servers. And as a test application author, you don't need to really keep anything locally. So everything is accessible through the cloud. It's Apex Code native. So this is a tool that is, the goal is to test applications on the platform that are written in Visualforce and Apex. Being Apex Code native, it allows for the test writers the interaction with the actual application under test to be easier than when you have to bridge technologies between the test script and the system under test. So for example, if you have your own developed test system, let's say written in Java, you probably have to use our APIs to actually interact with the system and set up data, tear down data, and so forth. So there's one more layer of complexity there. Being Apex Code native, you don't really need that. You just write your tests in Apex. You can reuse all those nice libraries that you may have already developed for developing your application, and things make you more productive. And it's opinionated, and that's a good thing in the sense, in this context. It's based on an opinion that we formed based on the Salesforce usage of WebDriver Selenium. We've been using it since 2007, I believe. It's been a long time. We do have over 70,000 tests written using that technology, and we execute that every day over a multitude of browser and OSs. So we learned quite a bit of how to write those tests in a way that they can be resilient and effective and efficient. So we're trying to bring that knowledge into the framework. So a few examples of those opinions. Cinnamon is based on the WebDriver API. So as you're writing the test, you're going to use the WebDriver API. So Selenium WebDriver has two flavors of APIs. One is an older one, but it's still being used, and the WebDriver is the new one that's going to be supported in the future. So we want to make sure that we use that one. We enforce the usage of page object pattern. Page object pattern is a design pattern for writing tests that are more maintainable over time. We do use CSS locators as the location strategy for locating elements on your browser, on your DOM. We do limit the test complexity as well. One of the things that you want to make sure is the test is not too complex, because these tests are really touching too many subsystems. You want to make sure that the complexity is not, as the complexity grows, the probability of the test causing issues also grows. So you want to make that trade-off there. And it's distributed system aware, which means that, as you've seen in the previous slide, where you have all those computing nodes, they can be running on the same system, or they can be running on different systems. They might have network issues, you know, a node may be down, so maybe the browser, the machine that is providing the browser services is slow. We need to take that in consideration. So we do have a lot of logic to make sure that we don't generate a lot of false positives, which means the test fails when really it's not an application issue, but it's a system issue. That's a very common thing for this type of tests. So now, all that talk, I'm going to jump into a few demos. And these demos are going to show how to write a cinnamon test and how you can integrate them into a continuous integration tool, because tests are only as good as often as you can run them. So let's see. So let's start by taking a look at this very simple Visualforce page. And it's just for the demo, it's a page that accesses the accounts and creates account. Basically has one input field and a save button. The idea is that it's very simple, just because the next piece of code that I want to show is what we call the page object. And the page object basically is, you can think of as the API to that page. It should model what your end user is going to be thinking and doing when they're accessing that page. And you encapsulate all the nitty and gritty complexity of making it work. So for this page object, you can see we have basically two elements, the elements that I just described. So you just declare the elements that we're going to be using through the system, through the test. There's a method. So you see this page object extends cinnamon.pageObject. So that's our base class. And there's an initialize page object method that is called throughout the lifecycle of the test, which basically connects the element that we're going to be manipulating here with the actual element on the page. And as you can see, it uses some locators that are specific to Visualforce. So instead of using, CSS locator in a raw way, we provide some utilities so that your test, you can write these easily. So basically, you're just saying, okay, for the comment button with ID save button, that's what I want to refer by save button, and account name input is going to be my input field with ID name. And the method that we have here is save new account. Basically, the user is going to come and is going to want to save a new account with a particular name. If you use WebDriver, you can see that things are starting to look a lot like your usual WebDriver. So you have a web element that has a send keys method. You have a button, it has a click. And lastly, we have a construct that is also common in these type of tests that serves to synchronize the behavior, the execution between the test and the actual browser. So here we're just saying we're going to wait until the title of the page contains the name, because that's what happens when you save, you use the standard controller. the detail page gets back and you get the title with the name. So it's a very simple example. Just want to show that. That's the first step into writing the test. And then you can write the test. The test really is going to be very simple. You're going to do a cinnamon base test. You're going to extend base test. Oh, it's not showing up. So there are two methods. The simplest test you can write, you have two methods. First one, you're going to override get starting path. Get starting path tells the framework what is the starting page that your test will start on. So in this case, we just ask new account page object, give me an URL. And what happens is the Cinnamon framework will take care of the authentication between your org and when the test starts executing, it's going to be on that particular page, which is, in this case, just Apex new account page. And test is the method where you actually execute the test. You exercise the system. In this case, again, it's very simple. We're just going to say, save the new account. So, like I said, these are actually not saved to my org, and because just going to save them. And because it's native, so all your tooling that you are used to writing your Salesforce applications, so if you use the Force.com Eclipse IDE, you can use it. If you use Maven's Mate, you can use it. It's just the same tooling. So now that we saved that, so this is the, too big. So this is what we call the test console in Cinnamon. Basically, it's a way to start the execution of a test. Before you can execute, you do have to. So this is the OAuth handshake that we make, so that we can, from the browser that we're going to control, we're going to pass a token so that it can actually log in and back into the system. And truly, I need to. I'm just going to, so we're using Sauce Labs. Anybody here heard of Sauce Labs? A few. So Sauce Labs provides that browser box. It provides a service where you can request, a OS browser version, and we receive a session ID, and then you can control that browser from Apex. So I'm just going to update that. Yeah. So my credentials for Sauce Labs, that's what I was missing. So now, the other cool thing about Sauce Labs, they provide, in addition to production browsers, they have the beta and developer channel for some of the browsers like Firefox and Chrome. So you can actually test your application on those browsers before they even hit, production. So in this case, I'm just going to do a beta version of Google Chrome and execute the test. So what's happening here is we are creating what we call a test suite. So basically, it collects. We're saying that this is the test that we're going to execute. These are the browsers. This is the user that is going to be executed under, and so forth. And does all the orchestration. And as you can see, it's actually an object here. So the suite. It's too big. And it's just saying you have an execution of this test and it's running. You can see there's a multitude of OS and browser versions. Sure. Yes, so that's a good question. So right now, this is a managed package. Right now, to get this, you need to install 2 packages. One managed package is a base package, and the other one is the actual Cinnamon package that provides all of that. And it's in beta, managed beta. Yes, they're up change, and we do have a site where you can also get them and get all the documentation for it. So the test is executing. You can see actually screenshots. So this is all provided by the company. You can use Sauce Labs. There are others. I think it's Browser Stack is a competitor. Or you can have your own, if you're feeling like you can bring up your own Selenium farm and use it. Of course, all of this like nice UI, you probably won't have it. Okay, so the test passed. We can continue. Will show you details. So this is all the commands that went on. You can see the actual window, and they do have. They do record. You can record your tests, so that's very good for debugging tests. Anyway, so that's the simplest test that you can write. I want to show another one where it's a little bit more complex, which is the edit version. So the edit version will need to, as a prerequisite for the test, we want an account to exist. So tests, Cinnamon tests, they are executed in different phases. And so you have a setup phase where you can see right here, so the setup is going to be called, and we're going to create the account. And just to highlight, the account you choose something that maybe you already have to, create accounts on your particular application. And you can just reuse it. So you're going to use that to create an account, and you're going to get the account ID and put on context, which is the way that we pass values from one phase to the other, because each phase is actually a different Apex transaction. So you do that in setup. Now getting starting path is also a little bit different, because you want your application to start on that page of that particular account that you already created. So you get the account ID here, and you tell the page object here, this is the ID of the page, give me the URL that I should start on. And on the test, it's going to be the same thing. The difference is that we'll be changing the name. So to make sure that the test worked, after we run, the browser version, like we save the new account, we can come back here and just do a query and make sure that the name of the account is the new name. So now that I saved that, reload here. You see the new account, the new test, and we're going to execute it. So while this executes, Let me go back to the presentation and just highlight a few differences between these tests and Apex tests. So the first one is you're actually going to get a browser running under a particular user just as if he had logged in. No more of that, run as kind of a way of running tests with Apex tests. Actually get the session that the user would get. The data that you're using in the test is actually committed to the database. So because we are talking about different transactions and process being outside of the main process, the way to see the data is by committing to the database. So the important piece here is that in addition to the data being committed, you probably need to clean up your tests after you've done with it. And as you can see, tests are slower. They're slower than Apex tests, but the comparison here really needs to be against manual tests. They're going to be much faster than running this test over and over manually. So it's still running. Come back here. So as far as next steps, so at this point, hopefully you've seen that it's important to have that sort of tests, and it's something that you guys should start thinking about. And we suggest that we can always start with small steps. So before you even get to the tool, what we do at Salesforce is we identify what are the priority test cases. What are the cases that come, Thursday morning, maybe after a patch release. You want to make sure that, that particular user flow is running, because if it's not running, it's going to be bad for your business. So identify those. Once you identify those, make sure that your Visualforce pages are built with testability in mind. And that is something that I actually missed. Is what it means is when you, for Cinnamon tests, we do use the IDs. So IDs are actually optional attributes in Visualforce, but we rely on them to make sure that we have a reliable way to find the elements on the page once they're translated into HTML. Once you have those, you can actually start writing the Cinnamon tests. And lastly, you want to integrate that into a continuous integration system so that your tests can be executed whenever there's a change. I guess we are running out.
What if your developers auto-generate their IDs every build?
What if your developer auto-generates your IDs?
The IDs are basically useless.
What do you mean by auto-generate and useless?
They use a framework to generate the IDs, and therefore it just auto-assigns random numbers which change every build.
Yeah, well, so that's the testability. That's not a testable application. That's what it needs to change. Test automation is something that needs to be, it's not something that you can plug in afterwards. The application needs to provide the testability attribute. Otherwise, it's going to be hard. Usually, people will work around that by, maybe trying to figure out what the automated ID is, but that's really not the best solution because things are going to break. And the worst thing that you can have is a test automation system that gives you more headache than actually value. So.
We have different workflows, different business flows. How would you test that when you have to test for multiple scenarios when you rely on a mental test? For example, I can't do test 1, test 2, test 3.
So you have different test classes. So each class is a test.
So if I have 3 different scenarios for one Visualforce page, I'll have to make 3 classes in order to test the 3 scenarios?
Well, the test, yes. So there's different ways to do this. You can either have 3 totally different classes, or you can have, if you're concerned with code reusability, then you can have a base class or utils that encapsulate that code that needs to be reused. Because the test actually is probably going to be a little different, right? The test method, otherwise it wouldn't add value. So, you should design your test in that sense. Having the test in the same class is not the only way to provide that sort of reusability of tests. If that's the concern, I'm not sure. But usually that's what happens. Maybe I can see who was first. So,
do your tests count against your Apex code limits?
No.
And also, how can you run a test as a different profile other than yourself? Is that possible?
Well, so that's that step that I took where you do the authentication via OAuth. You can use a different user. I just use the same.
Your example for all of Visualforce, is this like purely for Visualforce, or would you use this if you have pages that were in Angular or some other JavaScript framework?
So right now, our primary goal is to provide a seamless experience for writing tests for Visualforce. The way that Cinnamon is built, it's really able to automate anything on the browser, but we are not supporting out of the box right now, things like that. We understand that that's something that's very common, people using, so it's something that we're probably going to be thinking in the future. He was asking first, sorry. Yes, so the setup is one method, and the teardown is the third. So the test will do setup, get starting path, test, and teardown. Well, so that's what I was talking about. Sorry, about not supporting right now other frameworks. You only be able to get elements through those locators, and the only locators that we are exposing right now are Visualforce locators. No.
What if you have a component in an Apex routine that the ID, when you write the Visualforce page, you write one ID, but if you have like 5 different elements, it generates 5 different IDs.
Right.
How do you find the source?
So for those elements, we have companion web elements. So for example, table is one, right? A table, you can have multiple rows. So there is by composition, you provide the web element, the raw web element, and we wrap that in a table web element, and then you can get individual rows just by saying, table get row 1 or get row count. Yeah. So sorry, I jumped into questions. So, like I said, we are currently on managed beta. For Spring 15, we expect two things: the managed release of the package and eliminate the base package. We're just going to have one package. We're also working on the implementation of WebDriver. The internal implementation right now, so as you see, the web element exposes the WebDriver API. But internally, we're still currently using Selenium RC for some technical issues that we had in the past. Now we passed that, and we're working on actually implementing the WebDriver JSON protocol. So that's what's going to happen. And we're going to support multi-browser configuration. As you saw, on the test console, you can only select one browser. So we're thinking of, as you build the test suite, you actually want probably select a few different combinations of those. And in the future, after that, so the things that we are keeping in mind is, we have a test author persona, we have a test admin persona. For test author, we're thinking of generating page objects, those, the API, at least the actual elements that are on the page. We think that is something that is currently, it's very manual and can probably be generated. The actual API, meat, the things that the page does, that's something that really depends on the application, so that's not something that we generated. Lightning support, if you've been through Dreamforce, you know about Lightning, so behavior-driven development. So are you familiar with Cucumber? Anybody? So basically, we want to provide that level of abstraction so that we can, it's a nice level of abstraction to describe those priority user flows that we was talking about. And mock controllers. So as much as this is an integration test tool, we think that could be useful for testing Visualforce in isolation. So, maybe you can test your Visualforce page, your markup, integration with the browser without having to do all the heavy lifting on the background as far as, creating all the data that would be necessary for a Visualforce test. So maybe you just provide some mock values that will be enough to exercise this part of the world. The test admin is a different persona as the actual people executing the test. So somebody asked about the different profiles or multi-user configuration, have a Jenkins plugin and other integration with the CI issue. We do have, I forgot to mention, it's the command line tool, which is built with the streaming API. So you can, that's how the demo that I missed, I was going to show the integration of Jenkins. Basically, you can have a build step that executes the tests and will be waiting for the test to terminate so that the Jenkins can process the test results and be part of your workflow.
Do you also support the service without cloud console? And
Just Visualforce. Yeah. Whatever you can build with Visualforce. Right, but the Visualforce that you run inside, you can also access directly. So that's the way you would test it.
Are there any plans to open source this?
So the actual WebDriver implementation of the JSON wire protocol is something that we've been debating, and I cannot say we are, but I cannot say we're not. I'm all for it. We just see it. So the headless browser supports as long as you provide the headless browser environment. So the way Cinnamon is built, you're going to use a particular Selenium WebDriver server. If that server is providing the headless browser, you can do it. There's no limitation from this side. All right? That's it? Hey, thank you.